Hi, good evening. We're Euphoria. The given challenge by Daikin is to reduce power consumption in an air conditioner system. It can be observed over the last few years with improvement of quality of life, usage of air conditioning becomes more frequent. The consequence of air conditioning system is the increase of demand for energy not only for heating, but also for cooling, and what causes general increase of energy consumption for thermal stabilization for houses. More than 50% of energy is consumed in a building is due to air conditioning system. Therefore, our project objective is simply to reduce operating time of compressor while maintaining the cooling temperature of your room, as compressor contributes the most power consumption in air conditioner system.
All right, thank you, Kamarul. Our business value is very simple. Save power equals save money. As you heard from Kamarul, that the air conditioning system houses 50% of the power consumption of the entire building, and that is probably due to the compressor that takes 75% of that power. And if we can cut 1/10 of that power, that would save us a lot of money. Right, thank you.
Okay, thank you, Kishan. Okay, so the first solution we propose is by integrating the aircon system with some sort of thermal energy storage system with the inclusion of phase change materials or PCMs. The way the system works is like the PCM cools the room while undergoing a phase change from solid to liquid. Because when it melts, it absorbs heat from the room without increasing in temperature. So the idea is like this. In the early morning, when the outside temperature is lower than the melting temperature of the PCM cools and turns into a solid. When the temperature gets hotter as the day progresses, the PCM is ensured it is being kept in an insulator so that it does not melt unless we turn on the aircon. Okay, let's say we set the aircon temperature to 39 Celsius. The aircon compressor will keep turning on until the aircon cools the room at 39 Celsius. Then the compressor turns off, and that's when the PCM starts melting in order to maintain the coolness of the room.
All right, thank you, Hakim. When weighing in the pros and cons of what PCMs to use, one type of PCM we might consider using is octadecane. This is because it has a melting temperature of 28 degrees Celsius, which is almost the same as the outside temperature early in the morning. Secondly, it has a high relative latent heat of fusion compared to other PCMs, which means a lot to heat absorption and releasing heat per unit mass. But the disadvantages of this PCM is it can only operate at the temperature above 28 degrees Celsius. Below that, it wouldn't operate. And besides that, it is flammable due to it being an organic compound. Thank you.
Okay, thank you, Kishan. Another solution to reduce the power consumption of air conditioner is by using desiccant cooling system. This system can save up to 40 to 50% of the power. Desiccant acts as a drying agent to remove the moisture or latent heat in the room. Humidity can affect the speed of the evaporation process. If we can control the moisture in the room temperature will not be fluctuated a lot, and the operation time of the compressor will be reduced. And it usually comes in three forms: solid, liquid, and advanced desiccants. And I will pass to Alia to further explain the pros and cons of the desiccant cooling system.
Thank you, Yishane. So the main advantage of using desiccants in cooling system is that desiccants have high energy storage capacity when used in concentrated solutions. This high absorption capacity of desiccants allow the use of smaller vessels, which reduces the heat input for regeneration. Therefore, it saves more energy. Besides that, dehumidification of air by desiccants function more effectively as it saves up more moisture compared to dehumidification of air by the normal condensation in a normal aircon. Moving on to the disadvantages of using the desiccant system is that it requires regeneration of desiccants and also it requires a separate cooling system. However, liquid desiccants can be regenerated easier compared to solid desiccants as it has a relatively low regeneration temperature, so it can be heated and cooled independently while minimizing the overall energy consumption. Another negative impact is that liquid desiccants are less effective compared to solid desiccant in dehumidifying the air. So the desiccant droplet carried over by the air to the conditioned space may cause corrosion in the metal ducts, which can further lead to possible health risks.
All right, thank you guys. That is all for the presentation. If you have any questions or clarifications, please contact our group. Thank you.